Today I'm going to be talking about roots. And what are roots? Well, I'm sure you've heard of the word square root, right? A square root. What is a square root? So, hopefully, you know at least what a square root looks like. It looks something like that. Kind of looks like a little division house, right? But we got like a little V with a little like pocket area here, right? So, when we're finding a square root, essentially all we're going to do is we're going to look for a number that when you multiply it by itself two times, you'll get this number in the inside, right? That's why this is called a square root, right? Because we're finding a number that can be squared that will give us this, right? That number is 4. If you do 4 times 4, you get 16. And of course, right, 4 squared is 16, right? Because this expanded out, like if I made it longer, right, it'd be this, right? These two are the same thing, right? Which is 4 times 4, right? 2 times. This is what this exponent means, of course, if you watched the video. So if I said find the cube root, right, I would draw like a little 3 right on the inside, right? Right. So the way of what we're looking for is again over here. There's nothing written here, but there's actually a little invisible 2 right there. A square root, whenever it's has nothing in there, right? If you just draw a square root, it's implying this little 2 in there, right? It's invisible. But the word itself implies that you got to find a number squared that will give you this. So this thing is asking us find us a number to the power of 3, or in other words, a number cubed that will give us 125. That answer is 5, because if you had 5 cubed, it'd be 125. All right, because we're doing 5 times 5 times 5. Right? If you multiply these two, it'll give us 25. So 25 times the last 5 will give us 125. So that's all roots are, all roots, cubes. For a square root, like if you had a little 2 in the little box area there, right? This is called a square root. This guy is called a cube root if there's a 3. If there's a 4, any number bigger than 3 has no fancy name really. You just call this fourth root. If it had a 5, you'd call it the fifth root of some number, right? You're looking for some number. Your answer is what you're looking for, right? Over here on this side is whatever this number is to this power of 4 will give you this, right? Because again, if we had 16 square root, we're looking for a number squared that'll some number that when you square it, because we're looking for the square root, will give us 16, right? So over here we're looking for a number that if you cube it will give us the inside number, right, of this thing right here. So over here again you would look for some number. Your answer over here is some number when you take it to the fourth power will give you the inside number of the little box thing here. So yeah, that's all roots are in general. Another way you can rewrite them is you can write. Let me just rewrite 16 again, right? You can also find the answer by doing this. You can break this number down, 16. You can, right, because we know that 16 is equal to 4 squared, right? So you could just rewrite inside. You can just rewrite this, and these two cancel out. All right, they cancel. And the reason for is that a square root can be written as an exponent. So I'm gonna write this, right? This little guy becomes this, right? Up here I'm gonna rewrite it 16. You can rewrite the square root as a 1/2. This thing you would rewrite it as mystery number to the power of 1/3. And then I think you can see the pattern here. We would write for this one, we would write mystery number to the 1/4. If there's a 5, you do 1/5, so on and so forth. And when you multiply an exponent, sorry, I kind of just spoiled it there. When you have an exponent to an exponent, you just multiply the exponents, and you'll get 4 2 over 2, which again we know as, sorry, 4, right? Because I multiplied 1/2 times 2, right? And I got 2 over 2, and that's just 4 to the 1, or just 4, right? That's why the square roots cancel. So again, if I had another example, would be if I had the cube root of 125, if I rewrite it as this, right? These two, because they're the same number, I can just do that, and we get 5. The exponent number and this number have to be exact same for you to cancel them, and you're just left with whatever number this is, right? But that's a basic, short little introduction to what roots are. Nothing too complicated, hopefully.